Hi, welcome to my video on proving trig identities number 6. So I have a trig identity here which has a left side and a right side. But what I'm going to do is I'm going to work it out two different ways. And here we go with the first way. So we do left side. This is the left side right here, which is tan theta plus 1. And secant theta plus cosecant theta. That's the left side. And the right side is cosecant theta subtract cos theta cot theta. So what happens here? Which side do you want to work? Well, again, the more complicated side looks like the one with the fractions, so that's the one I'm going to pick to work first. Now here we go. So I'm going to change tan to sine over cos plus 1, and we'll change secant to 1 over cos, cosecant to 1 over sine. Now that's the first step. We have tan, secant, and cosecant changed to cos and sines. Now, notice we have a complex fraction because we have a fraction in the numerator, fractions in the denominator, so it's called a complex fraction. So one of the fundamental ways is to, when you're going to add these, is to add the fractions. So I need a common denominator, so I have sine theta over cos theta. And another name for 1, since the denominator here is cos, we'll make it cos theta over cos theta. And draw a line. This is division line here. And a common denominator here is cos and sine. So I'll multiply this one by sine over sine. And multiply this one by cos over cos. So that gives us sine times 1 is sine. Sine times cos is sine theta cos theta. And 1 times cos is cos. And sine times cos is sine theta cos theta. Now, these two fractions have the same denominator, so we add the numerators, so sine theta plus cos theta over the denominator of cos theta. Draw a line, which is this one right here. And this common denominator here is sine theta cos theta. And we add these two, so sine plus cos. And now we have two fractions, so one fraction is divided, so we'll multiply by the reciprocal. So the numerator is sine theta plus cos theta over cos, multiplied by the reciprocal. So the reciprocal of this fraction is sine theta cos theta over sine theta plus cos theta. And we're multiplying, so we notice this numerator is the same as this denominator, to cancel out. And the sine can cancel here, or sorry, the cos can cancel here, cos once, so that gives us sine theta. So we brought this one left side down to sine theta. So again, on a sheet of scrap paper, or if the teacher allows you, you can work this one down to get the same thing, same expression. So let's work, pretend you're on a sheet of scrap paper, or the teacher allows you to do this. So cosecant is 1 over sine. Cot is cos over sine. And so that's 1 over sine. And when we're multiplying here, this is cos over 1, so this is cos squared theta over sine. And the common denominator is sine theta. So we subtract these, and 1 subtract cos squared. And 1 subtract cos squared is sine squared over sine. And sine squared over sine is sine theta. So notice the two of them now have the same expression. So if the teacher allows you to do this, go ahead. But if not, excuse me, you have to reverse all these if you're only allowed to use one side. So we take this one, put it here, take this one, put it here, take this one and write it down right here. Notice in working backwards, 1 minus cos squared divided by sine. You can take sine and divide into both of these. So that's that step there. Then when this step comes in, all right, another step here now. And 1 over sine is cosecant cos, which is what we have here, and cos over sine is cot. So you can work it down as far as here for both of them if the teacher allows you. Or again, the fundamental way, the formal way, is to work it right straight down until this side becomes this side without showing you this. So there it is. You put this on a sheet of scrap paper, and this is the way I do it to reverse it. So I can do either way. If I was a teacher, I would have the students go all the way down like this, and this would not be seen on the paper at all. So since the left side equals the right side, it is an identity. But I said I was going to do it 2 ways, so let's turn this over and go to the other page. And I said, let's do it another way. Well, the other way, I just wanted to show you, it's just a slight little different way. You'll see it now when so we still go left side, right side. You always do that. And we have to change tan to sine over cos. And we change secant to 1 over cos. Same as before. But here's where the difference lies. So before I changed the 1 to cos over cos, and I got common denominators and worked it out. But right now I have a complex fraction. So the LCD for this numerator and denominator, the LCD is cos is on the top, common denominator. Cos sine is on the bottom as a common denominator. So the denominator for the complex fraction is cos theta sine theta. So if you take the cos theta sine theta, so again, cos theta sine theta times sine over cos, and 1 times, so what I'm doing, I'm multiplying the LCD by all parts of the expression. So cos theta sine theta times 1 over cos, 1 so again, what I did, the LCD is cos sine for all of these fractions, so I multiply cos sine by each part of this expression, and as a result, each denominator should cancel. So the cos cancel, so I get a sine squared, and this is a plus sign. 1 times cos sine is cos sine. Notice I'm not saying theta. And we do the denominator. The cos cancel, so sine times 1 is sine. And right here, sine cancels, and I get cos. And on the numerator, I see sine is common, so I factor the sine theta out. So I get sine theta plus cos theta. Sine is common, so I take it out. And this is sine theta plus cos theta. And this factor here is the same as this, so we cancel them out. So we get, and look back at the previous one, and you can see now that you can either work this one down to get a sine, or you can do it on scrap paper and do reverse steps like I did before. I just wanted to show you this different technique here. Again, here I multiplied, because it's a complex fraction, I multiplied each part by the LCD and cancel them out and simplified. And just go back to the previous page, and here I worked out each fraction, but I worked out the common denominators of each fraction, add them up and multiply by the reciprocal. So there's 2 ways to do it, but it will be your choice. And that brings us, here I would make the statement, since the left side equals the right side, better put that in the middle of the page. I would make a statement, since the left side equals the right side, it's an identity, which I already did on page 2 or 3. And that completes this video. If you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.